In this video, we are going to look at two rearrangement reactions for the synthesis of amines, Hoffman's reactions and Curtius reactions. Don't forget to like and subscribe to the channel after watching so that you can receive every update from this channel. These two reactions are rearrangement reactions because they involved intramolecular redistribution of atoms to produce different compounds. We are going to look at the mechanisms involved in each of these two reactions in the next slides. So these are the key differences and similarities between them. The two reactions, as we said earlier, are all rearrangement reactions, which produces amines. They all involve production of isocyanate as the main intermediate, which we are going to look at the structure in the next slide. But Hoffman reaction involves alkaline solution of bromine and amide. So the reaction involves treating an amide with an alkaline solution of bromine. That is for Hoffman's reaction. But the Curtius reaction involves treating a carboxylic acid derivative like an amide, or let's say chloride, with sodium azide. So I'm going to look at the structures of all these in the next slide. Okay, so let's look at the Hoffman's reaction mechanism. So as we said earlier, the Hoffman reaction involves treating an amide with an alkaline solution of bromine to produce an intermediate isocyanate, which undergoes hydrolysis to produce an imine and a carbon dioxide. So this is how the mechanism goes. If you have an amide in a solution of sodium hydroxide, which is the base, and a bromine, the amino portion can act as an acid and gives a hydrogen to the base. So for the first reaction, the base abstracts one proton from the nitrogen in the amide. This leads to the formation of a new bond between this carbon, the carbonyl carbon, and the nitrogen, as well as the breakage of the pi bond system between the carbonyl carbon and the oxygen. So that yields this intermediate with oxygen with a negative charge. Next, the oxygen forms back the pi bond system, and this nitrogen gives out this bond to one of these bromine. So we get this intermediate. So we have a new bond formed here. We have a new bond formed here with the giving of this pi bond to one of these bromine. So we get this bromoamide as an intermediate. Once again, the hydroxy group, which is in the solution, then comes and abstracts the remaining proton from nitrogen. The same mechanism as the earlier. This pi bond or this electron is given to this carbon with a breakage of this bond towards the oxygen, as shown here. So we get this intermediate. Now from here, here's where we had the first rearrangement reaction. The first rearrangement reaction is this acar portion bonds to this nitrogen, then this bromine leaves the solution. So we have this R group bonded to nitrogen as shown here. Then this nitrogen is to this carbon as shown here. Then this carbon is to this oxygen as shown here. So this compound is what we call an isocyanate. So the first rearrangement reaction involves the bonding of the acar portion to nitrogen, the nitrogen with the leave of the bromine. Then this nitrogen gets bonded to the carbon. Then the carbon is already having the oxygen. That forms back the new pi bond. So this is the intermediate isocyanate which is formed. The next reaction is basically a hydrolysis reaction which involves addition of water. So when you add water to this compound, the water splits into two, into a hydrogen and a hydroxide ion. Now the hydrogen attacks the nitrogen, whereas the hydroxide ion attacks the carbon. So we get this R bonded to this nitrogen with this hydrogen from the water. This carbon is this, the double bond to the oxygen. Then there's a hydroxide. The intermediate here is what we call the carbamic acid. The carbamic acid is intermediate from the hydrolysis of isocyanate. This is called a carbamic acid. So the alkaline solution then abstracts the proton from the carboxylic acid, and that leads to loss of carbon dioxide in the solution. In general sense, this proton is being given back to this nitrogen. So when this one leaves the solution, this proton from the carboxylic acid portion is given back to this nitrogen. So we get an amine and a carbon dioxide. So this is the reaction or the mechanism for Hoffman's reaction. It involves treating an amide with an alkaline solution of bromine to produce an intermediate isocyanate, which undergoes hydrolysis to form a carbamic acid, then rearrangement to form an amine. So you have the first rearrangement here, where this anionic intermediate forms isocyanate, then this one also from the carbamic acid forms the amine. So this is the mechanism for Hoffman's rearrangement reaction. Now let's get to the Curtius reaction and see how the mechanism differ from the Hoffman's. As we said earlier, they all involve the production of an intermediate isocyanate. So let's see. For Curtius rearrangement reaction, the mechanism is very simple. It is just treating a carboxylic acid intermediate, in this case it is acyl chloride, with a sodium azide. So it is NaN3, NaN3. I think it appears very blurry, but it is NaN3. This is what we call sodium azide, as we said earlier, or we saw earlier in the first slide. So when you add sodium azide to an acyl chloride, the next intermediate is called an acyl azide. So the acyl azide is just replacing the chlorine with the azide portion, which is N3, 3 nitrogen atoms. In between these 3 nitrogens, there is possible resonance. So the pi bond can flip in here. We have 3 bonds here. We get 1 bond here. So the distribution of electrons between these 3 nitrogens is by resonance. We can get 3 bonds here, and also we can also get 1 bond here in the same way as we see here. When we get the acyl azide as the next intermediate, the next reaction or the mechanism is loss of dinitrogen. So here you have 2 nitrogens here. You have 1, you have 2, you have 3. The next reaction is the loss of the 2 nitrogens living in the solution. Then we have an acyl group bonded to the remaining nitrogen in the solution. From here, then we get the first rearrangement. So the first rearrangement is the redistribution of this compound after the loss of the dinitrogen to form an isocyanate, which is achieved by the acyl portion bonding to nitrogen, the nitrogen having double bond with this carbon, then this carbon to the oxygen. So we have the R bonded to nitrogen here, the nitrogen bonds to the carbon. So from here to here. Then this nitrogen bonds to the carbon. Then this carbon continues with the oxygen. So this is the arrangement of the atoms in the isocyanate. So this is an isocyanate. This reaction is the same as that which was seen in the Hoffman's rearrangement reaction. When you hydrolyze isocyanate, the hydrogen attacks the nitrogen, then the hydroxy attacks the carbon. Water has two parts. It has hydrogen and a hydroxy. So when you add water to this compound, the hydrogen attacks the nitrogen, then the OH attacks the carbon. So we get a carbamic acid as intermediate. From here is the same as that which was seen in the Hoffman's reaction. Next, there is loss of carbon dioxide as we saw in the earlier mechanism. Then this hydrogen bonds to this nitrogen as in here. So this nitrogen attacks and abstracts this proton. So we get a carboxylate ion. Then this one leaves as carbon dioxide, and we have this one as amine. So amines can be synthesized from Curtius reaction by rearrangement or from Hoffman's reaction by rearrangement. This is just a representation of the Curtius rearrangement example. If you treat an amide, or let's say an acyl chloride, with sodium azide, you get a sodium or an acyl azide. This reaction might not continue if you add different reagents to this. So from here, if you add sodium azide to this compound, you produce an acyl azide. This one might not continue if you add different reagent at this state. So if you add, let's say, an alcohol to this compound, you produce an ester. And this ester is by the loss of two nitrogens and attack of this portion of the alcohol to the carbon, as in here. So it's very simple. If you add water to sodium azide 2, we are going to produce carboxylic acid. Thanks for watching. Don't forget to subscribe after watching so you can receive every update from this channel.